Welcome, everyone. I'm Dr. Bongo Research, and today we embark on a seismic journey to the greatest.
To grasp a volcano, we must first look deep within our planet, examining the crust, the mantle, and the superheated core.
Our crust isn't solid. It's fractured into colossal tectonic plates, constantly floating and interacting like icebergs on water.
The most common volcanic trigger is subduction, when a denser plate slides beneath a lighter one, descending into the mantle. Water trapped in the descending plate lowers the melting point of the surrounding rock, inducing the formation of molten magma.
This new magma collects in a vast subterranean reservoir known as the magma chamber, the heart of the future volcano. Lighter, less dense magma, rich in silica, naturally rises and accumulates at the very top of the chamber, closer to the surface.
The true engine of eruption is volatile gases. They are dissolved in the magma, but as its pressure drops,
Driven by buoyancy and gas pressure, the magma column ascends, fracturing its own path toward the weakest point in the Earth's crust, the main vent. As the magma chamber fills, the mountain physically swells or inflates. A crucial sign we monitor using
The magma's ascent triggers countless micro-earthquakes. A swarm of shallow tremors is the Earth screaming its final warning. A dramatic increase in sulfur dioxide and carbon dioxide emissions is detected, indicating that the pressure cooker is nearly full. The cap finally yields. Pressure instantly releases, ejecting vast quantities of rock, gas. This is the eruption column, a turbulent mixture of ash, gas, and steam, propelled by thermal energy and pressure to dizzying heights.
the most dangerous product, the pyroclastic flow, an incredibly hot, fast-moving avalanche of rock and gas that incinerates everything in its path.
Low-viscosity lavas, like those from shield volcanoes, flow like rivers of fire, covering huge distances quickly.
high-viscosity lavas, rich in silica, move sluggishly, forming thick, blocky flows that pile up near the vent.
Everything ejected is tephra, including these large, molten fragments known as volcanic bombs, which fly through the air like deadly missiles.
Fine ash particles travel hundreds of miles, creating hazards to air quality, machinery, and even causing structural damage as they accumulate.
Ash mixed with rain, ice, or melted snow forms deadly lahars, fast-moving volcanic mudflows that can engulf communities in minutes.
Volcano is formed by highly fluid, low-viscosity lava, resulting in broad, gently sloping mountains that resemble a warrior's shield. The stratovolcano, or composite cone, is the classic, steep-sided mountain, built up from layers of ash.
Cinder cones are the smallest type, steep but short, built entirely from loose pyroclastic fragments ejected during single, short-lived eruptions.
When the magma chamber is emptied in a massive eruption, the overlying structure loses support and collapses inward, creating a colossal caldera.
Not all volcanoes are on plate boundaries. Some form over hotspots, where a plume of heat melts the crust from below, creating island chains. The longest volcanic mountain chain is underwater. At the mid-ocean ridge, plates diverge, and
Volcanoes provide a clean energy source. Geothermal power harnesses the heat from magma to turn water into steam and generate electricity. Volcanoes are Earth's builders. They continually bring new rock to the surface, literally creating new islands and expanding our continents.
Volcanic ash and weathered lava are mineral-rich, creating some of the world's most fertile agricultural soil for farming.
We rely on seismometers buried deep within the ground to detect the slightest tremor caused by magma breaking through rock.
GPS and tilt meters use satellites to measure ground deformation, alerting us to the subtle swelling that precedes an eruption.
Remote gas spectrometers analyze the volcanic plume, looking for the telltale spike in sulfur dioxide that signals a pressurized eruption is imminent.
Beyond the heat, the gases themselves are deadly. Sulfur and chlorine create acid rain that destroys vegetation and infrastructure.
Volcanic ash is an extreme hazard to aviation. It can destroy jet engines and bring down planes, forcing massive flight reroutings worldwide. Most of the world's active volcanoes are found along the Ring of Fire, a gigantic perimeter of subduction zones around the Pacific Ocean.
We quantify eruption size using the Volcanic Explosivity Index, or VEI. It's a logarithmic scale. An active volcano is one that is either erupting right now or shows significant signs of activity within human memory. A dormant volcano has not erupted for a very long time,
but still retains the potential to become active again in the future.
Extinct volcanoes are those that scientists believe will never erupt again, having been cut off permanently from their magma source.
Basalt, a common volcanic rock, is formed from rapidly cooled, low-silica lava. Look at the fine grain structure. Pumice is essentially solidified foam. So many gas bubbles were trapped that the rock itself floats on water.
And finally, obsidian, or volcanic glass. It cools so quickly that mineral crystals don't even have time to form.
So, from subduction to magma, gas pressure, explosion, and flow, that is the incredible chain of events that defines a volcanic eruption.
Volcanoes are more than just destructive forces. They are the visible pulse of our planet's deep, internal.
If you found this research eruptive, please like and subscribe for more deep dives into the science of our world. Thank you.